divide our nodes into, or the structure into two, that is one explicitly for your express nodes and one explicitly for your normal nodes. Reason: see, if you see that some nodes are there in express nodes, means what? The other nodes are not in the express nodes. Now, since Rishita had asked this question, and actually after say today's session, I wanted to go back to what is that O notation. So, but since she had asked this question, let me handle this question straight away. Rishita, it is like this. Generally, which node should also be in an express node? Now there are different algorithms, but the one of the algorithms which is most popular is that suppose you have 8 nodes. Suppose you have 8 nodes, then 8 by 2, that is 4 nodes, should be in express nodes at level 1. Are you getting my point? Let me see. If there are 8 nodes in the normal list, then 8 by 2 should be at level 1. That is 4 nodes in should be in level 1. 4 by 2 should be in level 2, and 2 by 2, that is 1, should be in the next node. So this is a general kind of assumption that the number of express nodes every level should reduce by 2. Are you okay with what I'm saying, students? The general, how many nodes should be there in express nodes? So the general kind of a search logic is that if there are 8 number of nodes in the normal node, then 8 by 2 should be at level 1, that is 4 nodes in the express node level 1. 4 by 2, that is 2 nodes in level 2, and 2 by 2, that is 1 node in level 1. Okay, so this is the general assumption what we make. Now coming back, so this goes in a logarithmic fashion. This goes in a logarithmic fashion. Now coming back to Rishita's question, that if we have only one node, instead of splitting this into express node and the normal node, if we have only one node, the number of express nodes are very less. The number of express nodes are very less, and this reduces logarithmically. This reduces logarithmically. Since it is going to reduce logarithmically, so the if we have the pointers for every node to the higher level node, then lot of values or a lot of elements in this structure are going to be either 0 or null values. Either 0 or null values. Therefore, the connectivity from the node to the higher node is not there, but vice versa, from the express node we have a down to the node. From express node we go down to the node. Rishita, have I handled your query, Rishita? Yes, it is not doubly linked list. Yeah, I think the diagram which I have shown, it gives a two-way pointer. So probably that's the reason why you were thinking that it's a doubly linked list. So since it is a doubly linked list, why can't we have a connectivity to the higher node? You are right in that way. But it is a singly linked list which we are handling at the present. It's a singly linked list we are handling at the present. Second paragraphs. Now, just a minute. Her next question is, struct definition had a pointer to the lower level as struct node lower, and instead of lower I had put it down, and an int level. But if level is 2 or more, The lower level is not node. You are right. It is express node. So my idea is to generalize every node into one with properties level, lower, higher, next, previous, keys, values. Now Rishida, the same logic goes. Uh, for example, now when I come to today's class, actually, when I come to today's class, this point also will get clarified. See, in the express node, in the express node, we have a provision for level. Why do we have a provision for level? As I had shown it in this slide. See, this level is depending on your requirement. It two skip list means it has got only one express lane and it has got one normal lane. One normal lane is of course there. It's a constant factor. If it is two, if it is three, then we add one more level. If it is four, then we add one more level, and so on and so forth. So on and so forth. Right? So we always during the search operation, we go from the express node searching downwards. We go from express node searching downwards. So we do not go from the node to up. We do not go from the node to the express node to the level 1, level 2, level 3 and level 4 like that. It's exactly opposite. That is, we start from the highest level, whichever we have added, and come down. Why? Because the idea of putting an express node is mainly because to reduce the number of search operations, right? So to reduce the number of search operations, we have to start from the higher level down to the lower level. So by reducing Rishita from instead of two nodes to one node, because the number of express nodes are going to be same. Again, the same logic goes that lot of elements of the node will remain this thing null or zero. Right. To reduce the space consumption, we differentiate between node and express node. You're right. You understood clearly. Great. So let us proceed further. Let's proceed further. Uh, okay. Now, just a recap of what we are having in the express node. One is one element. The first element is for the level. The second element is for the key. The third element is for the value. Fourth for the express node next. Means this 10, the 10 as you are seeing it on the screen in the express node, this 10 is connected to 30 in the express node. So this particular pointer is pointing to the next node in the express node, right? Now the next element, that is express node down, express node down. Now uh, let me ha. So for example, we have 14 here, right? Now from 14, which is at level 3, level 1, 2, 3. From 3 level, if I have to come down, I'm coming to the express node only. I'm not coming to the main node, but I'm coming to express node. Are you getting my point? So that is that. Therefore, the data type of this down is the express node data type. And the data type of this next, next, is your node type. Is your node type. So they are uh, one node is meant to go horizontally in the same level. The second express node down is to come one level down in the express node. And the NXT is meant for coming from level 1 to the normal lane and what you are seeing at the bottom are the pointers which we are going to utilize, that is express cur, is I'm utilizing it for the temporary node. Express first, I'm using this pointer for which points always to the first node. Express last is the pointer which is going to hold the value of the base address of the last node. And temp1 and temp2, when I'm trying to insert a node between the two nodes. When I'm trying to insert the node between the two nodes, as I come to the code, I'll explain you how we are using the temp1 and temp2. Now coming to the normal node structure, a node is going to have key value and pointer to the next. Now I'm talking about the normal linked list. That is 10 is connected to 20 through the this next, right? And this particular node is having a key, and corresponding to key we are having a value, right? We are going to design our structure based on what dictionary? What is a dictionary? It is a pair, a unique pair means what? It has got a set of keys, and corresponding to set of keys, there are values, right? The keys are given to a hash function. The value of the key is passed as a parameter to a hash function, and this hash function is going to find out corresponding to this key what is the value. Yesterday I have shown this. Now one thing I'm going to do right from today onwards, in fact yesterday, uh, unit 1, since linked list you had studied also in your previous semester, therefore we did not share this recording. But from here onwards, the complexity of understanding is going to be higher. So what I'm going to tell my hardware engineers, that they are going to share all the recordings, not the PPTs. They will share all the recording on this KMIT website, so that you can refer it back and try to understand if you have not understood it before, because the complexity is really high. And I really wish that this corona thing gets over, and I can come to your classroom and look into your eyes and make you understand, because I can make it out with my experience that which is a student who has not understood and which is a student who has understood. Okay, I really crossing my finger that the corona damn thing should finish as early as possible, but it doesn't look like till November at least. Anyway, so notwithstanding, last pointer, uh, the last pointer. You are talking about struct node next, Aishwarya. In this slide, uh, no sir recording. Last recording also I'll put it. Unit 2, Unit 2, uh, yesterday's recording was the first one. That also I'll place it on the on this website, Aishwarya. Is that the query? Aishwarya, recordings you are saying, the last recording in the sense the yesterday's class, right? Ask if going to put the recording of unit 1 as well. Unit 1, I'm not going to put it. Reason being, it is all linked list, and you already have studied linked list in the previous semester. So unit 2 I'm talking about. Uh, Naga Venkat, I may not consider your request at the present. So recording of unit 1 may not be placed on the this thing. Okay, so now coming back to our today's class, the skip list one. This logic I told you, that the box 1 and unbox 1. So this I already explained. Now let me come to the code, right? Let me come directly to the code. Now in this code, I have a create node. For example, Shivani, I just now told Venkat that presently I'm not considering it. Presently, I'm not considering it. So, Shivani, uh, why don't you understand from what you already know and study that? Okay. Uh, let's talk about this in last 5 minutes of my class. Okay. Please do not post this request again and again. No, hash function is not a built-in function. As I told you, there are different algorithms for hash function. One of the hash function algorithm is is called as division algorithm, division hash function. In that division hash function, we as a user we decide that number which has to be the number which is required for the division, that is for counting the modulus, could be 6, could be 11, could be 7, or any other number as per the requirement of your logic. Okay, so it is not a library function. It is you have to work it out. Okay, I'm on my this thing. I change it to hello. I change it to the change my microphone. Is this audio better? Is this audio better, students, compared to the previous one? The previous mic, I was feeling that some of the students were not able to hear. Okay, this is better. Oh, great. Thank you. No, sir. The previous is better. Mahakali, or this is better. I changed the microphone and the mic is very close to my mouth. It's a headset. This is better. Okay, fine. Great. So the create node. What I will do, students, now the create node. Now, what is this car? Yesterday, I showed that in the one thing I would like to ask you. Let me show the complete code. My comfort is both. Shri Krishna, thanks for showing my comfort. My comfort is when students' comfort, nothing more than that. Okay, students. Uh, since I'm going to talk about the code, are you able to see the complete code very clear on the screen? So that I need not have to copy, because the code length is so much that in one shot I'll not be able to show you. Are you guys able to see this Dev Plus editor? Okay, great. Right. So let me explain you the code. Now in this code, what I have done here, min, right? Now a word about this, very, very important, because this is the starting point. This is the leftmost node. Or you may not understand what is this leftmost node. By default, one of the algorithm, when you create the skip list, in the create skip list, one leftmost node is taken as some infinity value. Now, as you are seeing it at line number 4, my infinity, just for the sake of convenience, I have put it as minus 9999. At line number 4, what I have highlighted with blue, the leftmost node, right, means even if there are zero nodes, the leftmost node by default is going to have an infinite negative value. So for the sake of simplicity, I have put this infinite negative value as 9999. Of course, it is not an infinity, but just for the sake of simplicity, I have put as 9999. And the rightmost node, this is not a part of our actual linked list. It is to start with, the leftmost node is taken as 99 and the rightmost node is taken as positive 99. So all the values are between the leftmost infinity to rightmost infinity. Okay, once again, the leftmost infinity I'm taking it as minus 99, and rightmost infinity I'm taking it as 99 for the sake of simplicity. Now, this is the structure. In this structure, there is right. Uh, Let me come to the create node. Now, in this create node, this curve, you can see it over here. I already in the what, in the global area, I have put cur, which is a pointer to the structure of node data type. It's a pointer to the structure of node data type. So what I'm doing, cur is equal to node pointer envelope size of node. Now enter the key. When you enter the key, scanf ampersand cur of arrow operator key. Why are we using a arrow operator? Ashdeep Singh, can I ask you? Ashdeep Singh, why am I using an arrow operator here? Only Ashdeep will answer, please. Ashdeep Singh, are you there? Can you hear me? Ashdeep Singh, are you there? Okay. P. Surya Teja. Yeah, why am I using an arrow operator here? To access this key. Pointer to structure. Good. So if you have created a pointer to a structure, to access the element of that structure, we are using the arrow operator. Great. So cur of arrow operator key, again I'm prompting enter the value and the cur of arrow operator value and cur of next. So when I'm creating an isolated node, go back to your linked list class. Whenever you are going to add a node, first you create an isolated node. So isolated node next is null to start with, because it is somewhere in the heap and we do not know where it is going to get connected, right? So to as a default, we are assigning a null value to your cur. Similarly, now this is as far as your create node is concerned. Similarly, create express node. Create express node. Now in this create express node, again I am taking the level input from the user level. The size we are not considering, though I have added it over here. So try to understand this particular part. What is this express cur of key is equal to cur of key? When do we have an express node? Every element of the express node is also there in the normal lane. Yes or no? So the express node key is not something which is very different. It has to be a key which is there in the normal linked list. Students, are you finding it? Are you understanding this? Anybody who is not understanding, please come in the chat window. The express nodes key is nothing unique, but it is one of the normal lane keys, right? Therefore, whichever is the key is there in the normal node, that only I'm picking it up and assigning over here. Okay, and the value and my express node next is null. So whenever I'm trying to add what an isolated express node, I can call the create express node function and create one isolated node which is not yet connected in the express list. Now, very important, please focus your attention. I'll give you 1 minute to understand what I'm trying to do over here. Longish code, you have to get used to this as far as the unit 2 is concerned. You have to get used to this longish code as far as unit 2 is concerned. So please go through this code and try to understand what every step is doing starting from line number 69 downwards. What is init? Init is initialization. Now, what is our first assumption? The first assumption, before we start adding nodes in the normal lane, we are making an assumption. What is that assumption? That the leftmost node has got an infinite negative value, say minus 9999, and the rightmost node in the normal lane is going to have what? A infinite positive value, which for the sake of convenience, we are putting it as minus plus 9999. Now, it is the case over here, which we are considering is two lane. That is only one express lane and one normal lane. One express lane and one normal lane, right? So, since the first node, the leftmost node is minus 9999, the same key should be there in the express node, which is again minus 9999. So the express node is going to have the rightmost what? The rightmost say node, which is also key positive 9999. Based on this particular background, please try to read the code. Now let me focus only from 69 to 83, line number 69 to 83. Are you able to understand what am I doing at every step? Somebody who's not understood can come to the chat window. Somebody who's not understanding, please come to the chat window. Okay, but let me explain this. Let me not leave it to you. The first line, I'm just giving a prompt. I'm just giving a prompt on the screen. So when you execute, I'll show you after executing this code also. It is a executable code, right? The first thing in the main, I'm calling the init function. The first thing what I'm doing, I'm calling an init function. Now, when the init function is called, the prompt which you will get on the screen is initialize first and last node and first and last express node. Are you understanding the difference between the node and the express node? The basic assumption is that the leftmost node has got minus huge negative value. Same is also there in the first level express node, right? If you recollect this particular diagram, which I had shown it earlier, see, somebody asked me what is sir 14, 14, 14, 14 is getting repeated. This 14, 14, 14, 14 is getting repeated. This is the very first node, right? So the very first node keeps repeating at all higher level nodes, right? So that this particular 14 which you are seeing it over here, I'm replacing that with a minus 9999. Students, are you with me? Anybody who is not understanding the leftmost node and the rightmost node? Somebody who is not understanding, please raise your query in the chat window. So the very first line, line number 69, I'm just putting a message on the screen saying that this particular init function, the idea of this initialization function is to create one extreme leftmost node and extreme rightmost node. Now we are considering two linked lists, that is the normal linked list and level 1 linked list. So the leftmost node is there in the normal linked list, at the same time express linked list. So that is what the job we are doing it over here. Now let's come to line number 70. What does this line number 70 do? The cur is equal to, I'm just allocating a memory address, right? From the heap memory address, I'm storing that into this cur. Are you with me? I'm storing that into this cur. Okay, so this cur has got a memory address which is pointing to the block which is storing the entire structure of a node. Now coming to line number 71. What am I doing? Cur arrow operator key initialized to min. What is the value of min? Bhavana, what is the value of min? Right, great. So this value 19 minus 9999 gets assigned to the leftmost node min. That is the key. And what the value? Again, min. Okay. And the cur of next is equal to null. Cur of next is equal to null at the present, right? Do not go much beyond. Let's focus only up to line number 83. Then I'm coming to the second part. Okay. So the first is equal to cur. What is first? First is the pointer. Sir, why we need to have leftmost and rightmost node? Good. Yes, Venkat Karthik. Very appropriate question. I was expecting this question from one of you. See, Venkat Karthik, whenever we are creating the nodes, we should have the starting point. If you go back to your linked list, in the linked list, we have a special pointer which points to the very first what node, Yes. So something like that. The first node is taken as a highest negative value. First node is taken as highest negative value, so that we always start from this particular highest negative value as a first node. It is not actually the node which is there in reality. The node which is there in the reality, we are going to ask the user which node you would like to add, and we start populating on that. Similarly, the rightmost node. Make it Karthik. So instead of creating a pointer or a double pointer, because pointer to a pointer we have to create, instead of creating a double pointer, what we do, we create the very first node as the highest negative value. Venkat Karthik. Right. Okay. So from up to 74, first is equal to cur. What is first? First is the pointer pointing to the very first node. Like in the linked list, we should always have a pointer which is pointing to the leftmost node, isn't it? Because that is the starting point in the single linked list. So like that, the first is a pointer which is always storing the address, that is the base address of the very first node in the normal linked list. Okay. Now coming back to line number 75. So when the initialization happens, just to confirm whether this 99 has got allocated to my key and the value is also minus 9999. I am trying to take the output on the screen to get it confirmed that yes, the leftmost node key is minus 9999 and the corresponding value is also minus 9999, and that is assigned to first, right? Now coming to the line number 77 to line number 85, 77 to 85. something very similar. Cur is equal to, again I'm refreshing it, and cur of key is equal to max, cur of value is equal to max, cur of next is equal to null. Now please focus on this particular line number 81. Last is equal to cur. Line 82. First of next is equal to last. First of next is equal to last. Somebody, Teja, what is this first of next is equal to last? Line number 82. Okay, Nikhil Reddy. Go for it. Linking what? Right. Absolutely right. They are presently in the initialization. There are only two nodes. The leftmost node having the key double nine minus double nine double nine, and the rightmost node having the highest positive value, say plus double nine double nine. So as Nikhil Reddy is saying, the first node is linked to the last node. The first node is linked to the last node. Correct. As far as line number 82 correctly understood. So then I am printing the key value and the value of the last node. Now line number 85. Last of next is equal to null. Why? Somebody else other than Nikhil Reddy. Why last of next is equal to null? Why last of next is equal to null? Somebody else other than Nikhil Reddy. End of the list. Very good. Since we have used the free function, okay, it is the last one of the node. Yes, end of the list. Good, because that is the last node. Correct. Last node pointing to null. Right. So when we are doing some kind of a search operation, or when we are doing something called a display operation, so display should stop. Display should stop. It should not ask for the next node, because there are no more nodes after that. Right. How will you understand? You can understand only if you have a null value. Means when you are advancing the pointer, if it comes till the time your cur of next is not null. Okay, till the time the cur of next is not null. For that particular purpose, we are, as per line number 85, last of next is equal to null. Right. Now this is what line number 69 to line number 85. We have finished by initializing the leftmost node of the normal linked list and the rightmost node of the normal linked list. Now let us go further, as I have written a comment on 87, express node. Now we are initializing an express node, like as I've shown it in the diagram. As I've shown it in the diagram, the leftmost node, all the first nodes are always there in every level. The first nodes are always there in the every level. So I'm taking it from there. So at line number 7, we have started doing initialization of your express node. How do I do that? So express cur, like the normal node, temporary node was cur. Since it is express node, temporary node, so I have named it as express cur. Express cur is equal to express node typecasting mlog size of express node, right? Then the same minimum value as the key. Now I have commented the value over here. I have commented the value over here for a simple reason, which I'll explain you little later after I finish up to 94. Okay, so express cur of express next is equal to null. Express cur of express next is equal to null. Express first is equal to express cur. Express first of level is equal to level plus 1. Express first of next is equal to first. Wow. Let's go step by step. Please try to understand. Please try to understand this. Now express cur of express next is equal to null. It is just initialization. we have not come to the last. We have not come to the last. Okay. So presently I am putting it as null, but later on I will connect it to the last node. Now express first is equal to express cur. Now when I make express first is equal to express cur, I already initialized the key with minimum value. Now why did I comment this line number 90 express cur of value? Anybody? Is it not required? Should I have the value here also? Should I have the value in the express node? Its value same as next of value. Very good. Rishita, absolutely you are dot on the line. Normal lane has it. Nikhil Reddy, very correct. Key already has the value. Absolutely right. So Rishita, Nikhil and Jai Shankar, you have picked it up very, very correctly and absolutely on dot. Therefore, since the value can be obtained from here, from the next, that is from the next. So therefore, I'm not unnecessarily storing this value in the express node. If at all I want to obtain it, I will go to the normal lane, pick up the value and print it there or you use it there, right? So this is what the express first has got initialized. Then I'm printing it for the sake of understanding that is everything going correctly or not, right? I'm printing express first key. I'm printing express first next of value as Nikita, as Rishita and Jai Shankar was telling me that this express first of next of value, right? From the express node, I have the value of the normal node. From that normal node's value, I can pick up the value, okay? And express first level, right? All the three things I'm printing. Now coming to line number 97, coming to line number 97, let me slightly take it up. Yeah, I'm focusing on line number 97 downwards. Express cur, I'm refreshing it. Express cur of key is equal to max. Now I'm initializing the rightmost of the express node. Rightmost of the express node. Now express last is equal to express cur. Express last of level is equal to level plus 1. Express first of express next is equal to express last. Slightly complicated. Line number 103. Please read it again. Express first, that is the express first, that is the leftmost node at the present, has to get connected to the last express node, right? So express first of express next is equal to express last. Key already has a value. Yes, yes, Shankar. Yes, I'm with you. Yeah. Express first of express next is equal to express last. Anybody who is not understood this line number 103, please come in the chat window. Anybody who has not understood line number 103, because you have to understand this. Because in the further coding, if you have not understood over here, I'm sorry, you will not be able to understand anything. 103. Any student who has not understood 103. Express first of express next is equal to express last, right? See, there are two nodes. This, assume that this 10 is corresponding to that minus 9999 and this 30 is corresponding to your plus 9999, right? So in this express node, now assume that in the initialization, these intermediate nodes are not existing. Only the leftmost node is existing and the rightmost node is existing. The leftmost node key value, we are given it as minus 9999. Same is over here, minus 9999. We do not have at the present anything here. And the rightmost node, positive 9999 and positive 9999. Now, line number 103 says that express first of express next is equal to this express last. The base address of this is being stored over here. So when I want to go to the next node, I have to have the address of this node. Bogaram. Am I clear? You want me to flash 102 and 93. Okay, let me go back there. 93. Yeah, yeah. Now, good. I should have explained you before. See, let me take it up because Bogaram has asked me the clarification. Bogaram, here this level which is in the global, I have initialized to 0. I have initialized to 0, right? So when I'm adding the first level express node, I'm adding the first level express node, line number 93. This level has to be incremented by 1. So this is my express level 1. In case there is a higher level required, at the line number 107, if you see on your screen 107, after doing this job, I'm incrementing it to level plus plus. So next time, if somebody asks for level 2 of the express node, I can pick it up from there. This is as far as line number 93 is concerned. Hariyara Bogaram. I'll explain 102 again, but is that 93 clear? Okay. Now coming back to 102. 102 says express cur of express next is equal to null. So presently, since I do not know the last node address, I am presently initializing it to null. 103 express one, yeah, yes, yes, Atal. Line 103 is linking the first and the last node. Yes. So at line number before I create the last node, since the next is 0, say next is not known, therefore I have initialized it to null. You can comment and do it later on also. It is same as normal node, but for express node, for linking the first and last node. You are right. Yes, Rohan. Yes, Rohan, you are right. Like how we have done in the normal node, a normal lane, we have to do in the express lane for level 1. You are absolutely right. Okay, so what I will do, I will compile this code and run it to show you what is happening in the initialization. Okay, just give me a minute. Let me compile this code. As you are seeing at the bottom of the screen, error 0, warning 0, and the compilation has happened. Now let me run it. Okay, are you guys able to see the black box with the values? Now the main is a menu driven program. I'll come to the main little later. But I just want to focus on the point of initialization. The very first line in main, I have given a comment that presently I am executing main. After that, initializing first and last node with first and last express node. Right? Once again, initializing first and last node, the, no the normal lane first and last node, and initializing the first and last node of the express node. Okay, come to the next line. I'm talking about this line. Okay, node first of key is equal to minus 9999 and first of value is minus 9999. Node last of key is positive 9999 and last of value is positive 9999. Now coming to the x is for your express node. Express node first is minus 9999 and express node value is this and the level is 1. So also express node last key is 9999, last key value is 9999, and this is 1. And this is a menu driven program. Insert the node, insert the express node, delete the node, delete the express node, then search the node and exit. Okay, in your what syllabus, you have in the skip list 3 jobs, 3 operations: insert, delete, and search. Right. So all the 3 we are going to cover in our code. So this is the output what you are going to get. I am going to give the choice as 6 and exit, because I have not explained you the other code. Anybody, as far as the output is concerned, any queries as far as the output is concerned, students? In case you have any queries, come to the chat window. Now, presently only the init function has got called, and of course the menu driven program in the main has got called. Any query as far as we are initializing the normal node, leftmost node, and the normal express leftmost node. We have also initialized the normal rightmost node and the express rightmost node. And the output which you are seeing on the screen is a confirmation that this thing has happened. This thing has happened. Okay. So I'm going out, and at the present, let me come to the main and show you why that menu driven program has got flashed on your screen. Yeah, students, this is the menu driven program. This but before that, in the main, as you are seeing at line number 337, as you are seeing at line number 337, init, this init has first called the init function, and init function has done that job, and then I'm entering in the while one, that is an endless loop with a terminating condition, and switch case 1 insert between, case 2 insert express node, right, then delete the normal node, delete the express node, and finally the search. Okay, so because of this you are getting that menu driven program, and that is what that has happened. Students, anything as far as, let me go back to the init function again. Any doubt as far as this init function is concerned? Those who have the any doubt anywhere in the code as far as init function is concerned? I called the init function from the main function, and that's how we came over there. Any clarification as far as init function is concerned? How is it possible? Yeah, there are some bright students who are picking up very fast, but let's not feel shy about asking clarification, because see, understanding somebody else's logic is the most difficult part. Some of you might have gone to the Google and downloaded the skip list code. Probably you might have got a different kind of a code, right? This is one more algorithm which also can work, Okay, now that the, yeah, somebody is firing a query. Let me wait for it. No, no questions. I'm seeing some activity in the chat window, so I thought I should wait. Students are trying to type. Okay, great. If you do not have any clarifications, then Sai Gautam, yeah, ending line 94. Okay, sure. Right, line 94. Line 94 says express next is equal to first. Good. Let me show the diagram here. We are at level 1. Don't, for the time being, ignore the higher levels, that is level 2 and level 3. We are at level 1. Now, what is this level 1? This level 1 has got this struct node next, right? This struct node next element. So this express node should have a pointer which stores the address of this 14. This express node down pointer, that is the pointer which is pointing to the normal node. So the base address of this should be stored over here. That is in the next. Now coming back to my code at 94 as you are suggesting, this express first of nxt is equal to first, right? That is how I'm storing the normal node base address in the express node first address. Gautam Verma, right? But this may not be required if you are at level 2. If you are at level 2, this may not be required because level 2 is storing the base address of